Okay, this is part 2 of the review from last weekend, actually. So what we're going to do is finish up this lecture as close as much as possible, or get through a little bit more of it. Then we'll have a lunch break in about a half hour from now. And then when we come back in the afternoon is when we're going to start using those accounts. So don't worry about it. If you still don't have your account set up, there's still time to configure it. I understand PuTTY is working for most people, so you might have to just go the PuTTY route if you can't get the SQL Workbench to work or anything else. Otherwise, just sell your Windows machine, get a MacBook, and then it makes your life a lot easier. So I know people hate it when I say that, but it's true. All right, anyway, pseudo columns. They act like a column in a database query. There's a command that returns specific values. So it's used to retrieve current system date, maybe the name of the current database user, and also new values and sequences. Remember, like I stopped last time talking about those sequences. So a pseudo column example, here we go. We have a current value, next value, system date, where we can actually call a system function and stick it in a query or use it to enter information into a query. So in terms of our pseudo column retrieving the current system date, we might say select sysdate from dual. But we don't have dual in MySQL, and we don't have pseudo column, so you can't necessarily run this on the server that you're connecting to. But if you were connected to an Oracle server, they would have a user table called dual, and in that table you'd be able to select the sysdate. And the sysdate is going to be the system date. Well, whatever today's date happens to be. So you can also retrieve the names of the current users who were installed. So select user from dual. And then dual is the system table that is used with the pseudo columns. So using the pseudo columns with the sequences, that also works. So you can, accessing the next value in a sequence, you can go to sequence name.nextValue. And essentially what you're doing with these pseudo columns is you're creating a column of information, and the information is the results from a query from a system table or from a built-in some functionality that existed. So inserting a new record using the sequence, we can say insert into my faculty values, and the values that I'm going to be inserting is, let's say for example, the f_sequence next value, which is going to put in an automatic sequence for next number for the next faculty, and maybe we're using it as a faculty ID or something of that nature. So we also have object privileges that we can work with, and you're not going to have anything available unless you're a root user. You're not going to have anything available in MySQL either for object privileges. So you created a database object. That's the first thing you actually have to do when you come in as a user, actually for these accounts I gave you as well. Create your database object. Now your database object's owned by you, and then inside of your database object you have tables and views and things that you'll contain. And so what you can do is grant, you probably can't do it because you don't have root access privileges, but I could actually grant different users privileges on the same objects. So you could share each other's objects if you wanted to. Sharing is not really part of the learning objective in this class, so we're not going to share anything, but we could. In a business environment, we could do that. So object privilege 1, privilege 2. We could grant these privileges on the object name. The object name would be your database object for the most part. And then this would be to user 1 to user 2, etc. And then the exact opposite. You can revoke privilege 1, privilege 2 on these different database objects from these different users as well. So what are these privileges? Here's some examples of some object privileges that you find in Oracle. The privilege might be alter, drop, select, insert, update, delete. Or you might have the all privilege. It's kind of dangerous, but it performs any database object, performed an operation on any object, and basically any operation. So altering allows you to change the database object using an alter command. Dropping an object, selecting an object. So all is kind of dangerous. So any database object and any command you want to do on that. So granting and revoking object privileges sort of look like this. Grant all on order ID sequence to L Howard. And then the SQL engine will come back. And if you're at a prompt, you'll see the same thing actually in MySQL. It's the same kind of interface. So the good thing about MySQL actually is if you actually have an SSH, you have a Unix account on that, so you can create an public HTML directory. And in your public HTML directory, you could set the privileges to open. And then you could actually set up a website on that server. There's no domain name going to it, so you'd have to type in 166 dot something or other, and then go into your account, and then you can actually, that's actually pretty useful. It would work actually, but we don't have it set up, or not really a database class, I mean not really a web programming course, but the interesting concept is because it's located on an external Unix server and if a server is available to the public, you could set up a website that would connect to your database object that you created through your server account, and then you could actually create an HTML interface to it, so it would go in, and using PHP probably would be a good language for that. So I wonder if we have PHP on that server. Maybe at lunchtime I'll play around with the server and see exactly what's on there. But it might be fun actually to be able to create a website or a web interface to your database object, but it's more of a theme for a web class. So. Now that we have server access for students, however, in the future I wouldn't mind seeing CS students here having their like a long-term Unix account, and then you can use it for hosting a website and playing with the databases and doing a bunch of stuff with it. So I think that would actually come in handy for learning purposes as well, because then you could take things between classes. Like after this class, you get your database all set up, everything's running, and then you would learn how to create a web interface to it using PHP, like a scripting language. Or you know, another language, HTML. You're not going to connect to a database using JavaScript. It's not going to work. JSP perhaps, but not JavaScript. You need a server-side scripting language. So here, retrieving data from a single table. We're going to select column 1, column 2 from a table where some search exists, some search condition exists. So retrieving data here, to retrieve every column in the table, we retrieve select star from the name of the table, or to select a column 1 and a column 2. And again, this is sort of review from last time. So qualifying table names, if we have objects that we have access to that are owned by other people, I could retrieve using the dot notation. So I could say, you know, select star from student 001 dot, and then the name of your table that you created. Let's say that student 001, she's not here right now, so I can talk to her about her. Created a my students table, or I could say select star from student 002 dot my students, if you all created that, and then I could query some stuff from that if I wanted to, because I have access to all your student objects. And if that were the case, then I'd have to preference which student I was talking about in terms of what table to get access to that. And you can also suppress duplicates by using the keyword distinct. And this is again review from the last time. We had like if you remember the bars, the beers, and the drinkers, we had a pretty good coverage of most of the stuff. Distinct was in there. Distinct is just going to return back 1. And using the multiple search conditions, we can use the and the or in there. So combining conditions for and. Both conditions must be true, or the or, either one condition or the other is true. And the comparisons for the evaluation as well. And refresh your memory on the null records. On the sample database that we created in the first part of this lecture, there was nothing set to not null, so everything could be null. Null means it's undefined, which means you don't have to put a value in there. So if you're going to substitute a value and you could put the word null, it's not a value, it's an empty value. And so you can use an is null search condition to see how many things are null. So select this name and the class from students. If I were to run this, most of it, the class is null because I didn't set any classes. It would come back and tell me, you know, 5, or not 5, not going to give me the number, it's going to give me the student names and the classes of everybody in there, because I didn't give anybody a class. So you can search for null and not null records, so you can say that it is not null. So where s underscore class is not null. So null and not null come in handy for being able to do some database cleanup work. And then you want to scrub the database, fill in some empty values, so check for nulls and not nulls. The other approach to doing that is not having to do the cleanup work, but not allowing nulls to be entered in. So if you set everything to not null in the columns, then you know that you're not going to have a situation where you're missing a value. As an example, if I go back to my class database and I look into, I'll just look over here, another one, and I look at the structure of it, I see I have default set to null in here, so I actually have to change this one to not null if I wanted to. And then that would make it so I couldn't put an entry in unless there was a value for this condition, for this column. And if there was a value, then there's no values in here. I think only my faculty has values. So if there wasn't a value in there, the database would complain. It wouldn't allow me to insert the record. So here's the in and the not in operator. So in retrieves all values where the search column matches a set of values. So select star from enrollment where the grade is in, and then we have a set. So think of the in as a set. So we have a set of A, B, C, D. If it's in there, then it's going to be selected. Or the not in retrieves the values where the search column value matches a set of values, but it's not in A, B. So it would be C is not in A, B here. So it would return anything that wasn't an A or a B. This comes in handy because then you want the ones that, retrieve everybody who's not a valid person. If I was going back to the database cleanup, and if that were the case, then I would find values that weren't set for sophomore, junior, or senior, let's say for the class level. So using the like operator performs an inexact search by matching parts of the character string. So it says where this field name is like this character string. So where class name is like, but maybe they misspelled it. So again, another useful query to clean up the data, essentially, because you're going to tell where something is like or not like something. So you can use the like operator with a character string. So you can have a single quotes or you can have a wildcard character. So this, another refresher of your memory here, this one here is the everything is like the asterisk. So it represents multiple wild characters, and then the underscore only represents one character. So it represents a single wildcard. And the wildcards can be placed at the beginning or the end of the string. So we have where S underscore class is like some character starting with R. So it could be junior, sophomore, whatever the character happens to be. Or here's J with something following it. So what if they misspelled junior or something? So the actual kind of way people do this now is if you were writing a web page and it was connecting to this database and you were trying to put the data in, you'd fix it so that you had a multiple select where it said, select your class. It's kind of like select your state. Well, there's only a certain amount of state abbreviations. So if it puts CA, CO, AB, all the states in there, and you just select it, you're guaranteed to get the right entry. So it kind of fixes what you can type in there. So if I had one for class, it would be saying sophomore, junior, senior, or something, and it would be written in there, and I'd do a multiple select on it. So the person can't misspell junior or sophomore or something. Which is actually kind of funny because you see a lot of databases where it has you type it in, and often I wonder, what if I mistyped it? So it'd be nice to have your password typed in correctly all the time. But anyway, so sorting the query output, you can use the order by clause and specify the sort order. So you can order it by age as an example. And this is, again, review. So select the name and the age. And remember, if you have an order by, you actually have to put it in the select clause, the same field that you're ordering it something by. Because what ends up happening is then it won't select it. There's nothing to select for the order by. So that's one of the requirements of that. And also group by. So group by is a definite requirement. Order by makes no sense unless you put it in here. Because how are you going to order it by the age if you're not selecting the age? So if you think of the logic. So sorting query data, you can sort in ascending and descending order by adding in the keywords at the end of the query. So here's one where it says descending. So here's the same query, but it's ordering by age in a descending order. So you're going to go to the highest to the lowest instead of an ascending, which would go from the lowest to the highest. If you leave it out, it automatically goes in ascending order. So you can leave it out and have that assumption, or you could put it in there and specify which order you want if you don't remember what the default's going to be. So we can also use calculations on the queries, as we saw with the addition, the subtraction, the multiplication, division. So here we have a select an inventory item with a quantity on hand times the price from inventory. And so then we can use, oh well, as we mentioned last time, we can use as quantity on hand or something, or as total. So we could put an alias in there to name the column when it comes back. Otherwise, how do we know the meaning of price times quantity on hand or something? Maybe it's subtotal or total or something. So we have single row number functions that we can use for absolute, ceil, floor, mod, power. And so when we use the single row functions, here's an example, truncate, where it's going to truncate it down to a date. So we take the system date minus the date of birth, divide by 375, and we get the age of the person actually. And then we're taking it, from the date of birth, we're calculating the person's age. And we're truncating it because we don't want to know that they're 21 and a half. They're just going to be 21. Or 21 and 3/4 or something. Yeah. Usually when you're a 5 or 6, you're a 5 and a half, 6 and a half. But then you get past a certain age and you no longer count the halves anymore. Instead, you just start lying about your age at that point. I'm only 21. Oh, okay. Good deal. Or you have the same birthday over and over again, and then you're really just the same age. You're not growing any older. So. Alright, so single row character functions, concatenate, length, left pad, right pad. These are used a lot, right trim, left trim. Because if the space is holding 20 characters and you're only getting back 5, and the rest of them are all empties, then what's going to end up happening is you're going to get a bunch of empty spaces coming back. So you could just trim it off and you can use it for some sort of insert into another field or something, or displaying it or something, whatever happens to be the purpose. The lower and the upper work actually work well because you don't know if anything's case sensitive. So if you just take the whole word and translate it to upper and then compare it against an upper or a lower to a lower, then you know you're going to get a right comparison. Because how do you know if the person capitalized something or didn't capitalize something? So using a single row character function where we can say select upper, which is going to take all of the first names or student names and give them to me in uppercase, and then it's going to be from students. Date arithmetic is kind of interesting. We can find a date that is a specific number of days before or after a known date, and then add or subtract the number to the known date. So here we have the sales order plus 30. Well, what's I going to do is going to add 30 days to it. So not knowing that you can do that might limit your capabilities in terms of writing a query to say, give me all the invoices that are going to be due next month. Well, it's easy. Just take the order date plus 30. It's going to be due next month. So, and this is from customer orders. So we can also find the number of days between two known dates by subtracting the later date from the earlier date. And so we can have select the system date minus the student date of birth. Well, that's going to give us the number of days between from the my students table. So another way of getting how old somebody is. We can say from a date function, we can say add months as an example. So it returns the date that is specified in the number of months after a given date. So add 6 months. So you say, well, I'm going to graduate in 6 months, or the class is 6 months long. So I can add months to the system date of today and say, well, what's it going to be in 6 months further down the road? Well, it'll return the date. So you're going to select the add months from the system date. So add 6 months and return the date for you. And this is from Dual because Dual's holding on to all of the information related to how many tables you've got, what is in the tables. Dual actually keeps track of how many users there are, what do the users contain, what's the current date and time of the system of the server, and what's going on with that. So in terms of the date functions, the last date, the last day returns the date that the last day of the month specifies. So specify the last date of the ordered date. So gets us the last day of the month. So if we have 30 or 31 days or whatever it comes back with. Because sometimes people want to make a calculation and say, well, you bought it in July. What's the last date of July and plus 30 to it? And then that's the due date of your invoice or something. If you don't want to use the date that was inside of the month. So date functions, you can do months between, returning the number of months between two input dates. So you bought it here, you returned it there. That was more than 6 months. No, we're not taking that product back from you. You're making a retail sales returns policy or something. They put the day's date in automatically, and they scan the receipt, and the receipt says, oh, it was bought on this date. So the SQL query would run the dates between or months between, come back and say, nope, sorry, can't return the item. So that the teller, the salesperson or returns person wouldn't have to calculate anything manually. This is done a lot actually in returns, in return applications. So as a sample, we can select the months between an ordered date and a system date and see how old the order is. So we also have group functions that we can apply. So it's used to perform an operation on a field from a group of retrieved records. So we have average, count, maximum, minimum, sum. So give me the sum of all these values, give me the average. So select average, maximum, minimum, sum from of the age from my students. So here's the group by clause, very similar to the order by. The order by is going to order it by a particular select condition. The group by must be used if some of the columns in the select clause are used in a group function and some aren't. Then we need to know how to group it. So we're going to group it by whatever field and this is the one I was saying before, it's just required. So group all fields that are not included in the group function. So here we have the select, and what is it going to be? It's going to be the class, and we're going to get the average age of the class of each one. And this class is going to be status, like sophomore, junior, senior. So what's the average age of the freshmen, the sophomore, the juniors? And we're going to group it by sophomore, junior, senior, and then the average age that's next to it. You can also put a sort by in there too, which is the sort by is not going to do the group. So this is usually something that usually ends up on the final exam where people they look at that and they go, you can't use a sort with a group, can you? And they go, well, and then they go, oh, what's the rule for the group? Well, the group has to deal with the aggregate. The sort can be in there whether you have a group or not, and it can come before or after the group. But usually people put it after. Sort by this, sort ascending, because you're going to sort the group by ascending, or sort descending. So the sort is going to not necessarily represent what's going to be shown to you. Group is going to represent what's going to be shown to you. The sort's like what format it's going to be shown in. So here we have an example of creating alternate columns as well. So I showed you this actually last time as well, where we're selecting column 1, column 2, column 3 with a heading. So here we have, what if we don't know system date minus system underscore date of birth? So we don't know, that's somebody's age. We could call it, and actually there's two ways of doing it. We can use an alias and say as. So, and I showed you the as last time. So it says select system date minus student date of birth as student age. Or here I could just say student age, which is basically an alternative way of doing it, just to say that we're going to call it student age. So that when we see our results, we're going to have student age 21, 22, 23, and these are the different ages that come out. Instead of this as the title, it's just the header. It's just the heading that you're going to get on your results. So it makes it more intuitive, I should say. If you're going to use the PuTTY interface and you're going to actually kind of see the results, you're going to be looking at that going, what is that? Well, you can say it's student age. You know what that is. So creating a column alias, this is the as. So this is just renaming the header. So it's creating an alternative column heading. And this works in the SQL Plus window. In other windows, like in your MySQL window, you're going to use as, and you're going to create the alias. So the alias is going to be the alternate column name that can be referenced in the order by or the group by as well. Because it's something you can use if you actually create the alias, then you can use it in your grouping. So select column 1 as alias 1. So if we said select system date minus date of birth as age alias, we're going to call it age alias, then we can order by age alias. If we just leave out the as, then it's going to show up as the heading. It's going to look different, but we can't use it in anything. It's not an alias, it's just a rename of the column. So we don't have full capabilities that we would have if we used as and created an alias for it. So dynamic SQL queries also exist. So these are queries that allow users to specify the search conditions at runtime. So you can write up these little scripts where you can substitute values in and then have runtime variables that occur. So here's an example of a substitution value. So you create, it's created when the search expression is prefaced by this ampersand, and the system then prompts the user for the value. So you can actually try this out if you populate the table a little bit and create the table. But we can say select building, some capacity from location where the building is equal to, and then here's the ampersand, building code. Say what building code? Well, the user's going to have to put a building code in when you run the script. And then group by building code. So you run the query and then you get enter the value of the building code. And the user has to enter the value in. The value gets entered in and substituted for the ampersand building code so that it can be used in the query. So a lot of people who have this command line interface for, I don't know, receptionists, non-technical people, administrators, administrative staff who doesn't know anything about a database, you could still write a script for them. They run it and they say, drop student from class. The first thing is going to ask you, which student? And you put in the student ID. And then the student ID would be substituted in, and the student would be dropped from a class or something. Or mark student attendance. What's the student ID? Okay, here it is. Oh, and it marks the attendance for you. So it's a nice way of making the script more dynamic at runtime. So we have the old value that was the building code, and then we have the new value here. And then the new value gets substituted in, and the value gets created. So using runtime variables, a runtime variable is a variable defined in the SQL Plus window. So we define the variable name, and it's going to be equal to a variable value. And as I mentioned before, a lot of people go, variables? How could we have variables? This is SQL. Well, we can have dynamic scripting that creates values for us, ask the user for it. And then we can also just set a variable, which is kind of interesting because then it turns it into more of a programming language versus a scripting language. As an example, I'm logged on to my wellsfargo.com account. Well, some of my variables might be my account number or my name or something, and then I can use those variables, maybe the account number, over and over again so that I can run more queries without actually having to figure out what the account number is. Otherwise, every 5 minutes it'd be, what's your account number? What's your account number again? What's your account number again? So instead, I just put the account number in once, takes it from a form, creates a variable out of it, and just uses that while the session's going on, perhaps. So then you can substitute the variable name in for the value for the query. So here's an example. We're going to define maximum capacity, and maximum capacity is equal to 50 in this case. So we can select the building code, room capacity from location where maximum capacity is larger, the capacity is larger than maximum capacity. Well, we defined maximum capacity up here, so if this is equal to 50, then 50 will be substituted in the where clause. So if it's substituted into the where clause, then it'll give us the buildings that we come out with. So you can always change this and you get different results that come out of the query. But when we define maximum capacity, this is actually kind of like how we're creating a variable. There's no data type to this. It's just a name associated with a value, and then the value gets substituted in. So if this maximum capacity was a string, and I made it into somebody's name or something, and then I used it in here, I'm going to get some really interesting results if I don't get an error message that comes back, because I'm not checking to see if a number is larger than another number. I'm checking to see if a number is larger than a string. So I'm probably going to get an error message that comes back out of that. So you can also format the data using a toCharacter function. So I can get by with that problem by taking the character and turning it into a number. So if the character was a text string and it was the number 50, I can just turn it into a number. Or if it's 50, I can turn it into a character to compare it with another character. That would actually be a string because it's two numbers. So if I had like maybe 1 through 9, 0 through 9, I can probably use that as a character and change the character and change the string and put it into a character value by using this function here. And the function here is toCharacter with a field name and then a format mask. So down here I have an example here. It says the time. Put the time into the hours and the minutes along with the AM and the PM. These here are probably the trickiest kinds of ways of doing queries, because then you have to know, well, what format was the time in and what's the available formats options I can use so that I can substitute in the right parameter for the right formatting. And then that ends up being time consuming because then you have to figure out, well, what database is this? What formats do they support? How did I make it in the table? Because it has to match what's in the table when you created the table. So last time we also talked about joining queries, so I want to briefly review the query joining concept. So we retrieve data from multiple tables by joining the tables together using a foreign key reference. So we're going to join the queries from an inner equality, outer equality, or self or inequality. So inner is on the equals. So one row is retrieved for each matching row. So we're usually in a query that says where student ID in this table equals student ID in that table over there. So we find a value that's equal in both tables, and we call that an inner join because it's a sequence together. So here's the order source ID and the order source ID from one table and customer order table linked together. So inner joins on the syntax looks like this. So we have select column 1, select column 2 from table 1, table 2. Where table 1.join condition is equal to table 2.join condition. So as mentioned before. So you have to include the two join conditions for every link between the two tables. It only gives you the joined columns. If there's an unmatching number of rows, it's not going to give it to you. So it's only giving you where the equal actually is equal. So anything equal over here, but we have multiple over here, not really equal. So select the student name, student name, faculty name from students and faculty, where the student ID is equal to faculty ID. Well, we're finding all faculty who are also students. These are in both tables. So if you have n tables from the from clause, and n-1 join conditions is going to exist. So you can qualify the field names when you're doing this. So if a field name in the select clause exists in multiple different tables, you can say which table is it from. Remember before we did the alias, so we said beers is B1 and beers is B2. So we took the same table, queried it on the same table. It's the same concept. However, we can use it with generic objects as well. They don't have to be the same object, queried on the same object. It's called qualifying the table name. So here we have student.s_id. And then we have enrollment.s_id. In the previous example, we had student and faculty, but it was called f_id instead of s_id. So we had different names. But if we have the same column name, and people do this because they want to link the columns together because it forms the keys. So if you have the same column name, then you have to specify which table you're talking about. So in terms of processing for designing complex inner join queries, you identify all of the tables involved and to label them. So you display field, the join fields, and the search fields. And then you write the query, so you select all the display fields in the select clause. You list all the tables in the from clause, all the join conditions in the where clause, and then all the search fields in the where clause. So whichever one we're going to use for the condition. So I know it's kind of a textbook way of doing it. Which is why I want to give you some hands-on kind of practice later. You'll be making multiple tables and you'll be joining them together. So you'll see how the system works. In the beginning, what you're going to do is end up just designing out the tables from an entity relationship diagram and then looking at the key structure and stuff. So on the outer joins, the limitation of the inner joins, some of the records may be omitted if corresponding records don't exist in one table. On the equality or the inner join, you only get the matching sets. So you can do an outer join, just give me everything else. You know, the matching sets plus everything else that doesn't match. Give it to me at the end. So you retrieve all the records from the students along with all of their enrollment information. So in this particular case, student 105, this Michael Connolly guy, does not have any enrollment records, so he's not going to come out of an inner join. So if we do an outer join, we could get him. He's a student in the system, but he doesn't have any records. So here's a no records retrieved on a regular equality join. So if we want the extra, we put a little plus next to it. So it includes the records in the first and the second. To get the outer join, we do this. Here's the plus. Same query as the inner, but we turned it into an outer join. So the inner only works on equality. The outer works on everything. So the plus says, if you want to think of it this way, is like, give me all the join plus everything else that doesn't match. which means I get down on the bottom. This is the only guy who didn't register for something. But I get him showing it with nothing because I put the plus here. So, which is a way of creating an outer join from an inner join, because it's the inner join plus all the other stuff. So in Oracle, you just put the plus out there. So you don't have to worry about designing a new query for it. It just turns it into an outer for you. If you want the inner, leave it out, and you get only the equality match. So inner you might think is the equality join. It joins on a particular field. And then the outer is the equality join, plus everything else that goes with it. Self joins is joining the table on the table. We actually had this with the Beers table when we made a query on B1 and then we made a query on B2, which is really the same query, the same table. We just queried the table twice. So it's used to join a table to itself when the table has a hierarchical relationship with itself. So we have a parent ID with a project ID. So we have projects and we have manager ID, and the manager is a project manager for a project. So we can put in the parent ID, the PID, into the manager ID. What project are you managing? And here's all the projects, and each one of the projects has a manager. So we can essentially, this is a recursive relationship, by the way, where the table has a relationship with itself. And if that were the case, then this is what's referred to as a self-join. The table itself is joined to itself. So to create a self-join, to query this, you need to create a table alias. We saw this with the Beer 1 and the B2. Beers B1 and Beers B2. So we have table alias 1, table alias 2. And then we simply just query the B1 and the B2. We just find some equality with B1 and B2. But B1 and B2 are the same table. So we find where the sub-project matches the parent project in this particular case. That's referred to as a self-join. And here's an example where we're selecting the parent project, project name, the sub-project, project name, from the sub-project and the parent project tables, and we're calling them sub-table and parent table, but it's really the project table. So the project table has an alias called parent project, and the project table has an alias called sub-project. It's kind of like Beers B1 and Beers B2. And then we're going to say B1.parent ID is equal to B2.parent ID, which is a field in the same table, but you're comparing the fields. So you're going to find matches, or you're going to find where they join together. And then the project example is hardware support with hardware support and interface. So those are the project by the sub-project managers. Alright, so the join and the inequality join. This is a join created by placing a marking join condition outside of the inequality condition. So it only makes sense when you have a foreign primary key values and they're not surrogate keys. So inequality means one is less than another or one is greater than another. So, or something of not in of inequality, not equal to a surrogate key. So here's an example. Select faculty last name and faculty location ID, location ID, from faculty and location where faculty location ID is less than faculty location ID. Inequality is anything that's not an equal sign. So if something is greater than, something is less than, or something is not equal. So we saw nested queries as well in the SQL lecture we did last time, and we created a query and then we selected a query on a query. So we have the main query, so it's the first query in the select clause, and then the subquery, which retrieves one or more values that's substituted in and used in the main query. So nested queries here were in the where clause, and we saw an example of this actually last time. So select this column, that column from this table, that table where some condition exists, and the condition is in or not in the subquery results. So the subquery gets executed first, and then the results get sent back to the main query. So here's one where we can use multiple results. We cannot use an equality on this if you have multiple results come back. So if you use that something is equal to something and you get more than one something coming back on the equals, the computer's going to give you, well, the database is going to give you an error. and say, sorry, there's more than one we were looking for, and this equals that kind of scenario. If we do in, then we get the set. So in the set, not in the set is going to come back to it. So the subquery that returns multiple values, usually seen in an in, not a like, not a equals, so, or not a not like either. So using set operations in queries, you can perform on the output of two unrelated queries. So the same number of display fields, maybe besides corresponding display fields must have the same data type as well. So both queries have to have the same. Which means you have to have some sort of a way of comparing it logically. You can't have like an integer value being compared to a bunch of strings or something. That's not going to work. If we do this, then we have one query that is compared against another query. In this case, we can union it, union all, intercept it, minus it, and then we're really working with sets on this particular case. So in a normal select clause, we retrieve the records that are not locked and that are available through the other users to view, update, and stuff. And then sometimes we need to select records. We can immediately update when it's based on retrieve value. So as an example, selecting records for update would lock the record so nobody else would see it. If we had an airline reservation as an example, or inventory items that were for sale, if we put a for update clause in there, when we selected it, it wouldn't show it to anybody else. It locks the record. The table's available, but this one's not. So if you looked at a seat on a plane and you're gonna select it for update, then you're gonna make it so that you're not gonna have a race condition with somebody else who selected it. If it's selectable, you can select it, and if it's there, and if it's an open seat, well then lock it, because we might need to use it. And then no wait or wait means, are you going to give the user something like, hey, the database is locked, or are you just going to deny it completely? Wait, for the database to become unlocked. So it gives us an ability to kind of control the user's experience in terms of the feedback they're going to get. So here's a search where a search on and join conditions exists for an update on column 1, column 2, column 3. And then we're going to say no wait, which means just tell the user that it's locked and don't let them hang there waiting for it. So selecting records for update, all retrieved records are locked until you issue a commit command. So you have to actually issue that commit, and the fields listed in the for update clause are for documentation purposes only. No wait clause is optional, makes it so that when other users try to retrieve the locked records, their system just doesn't hang, they actually get a message. So no wait is going to make them hang. So I also talked about the database views last time as well, and the logical tables based on a query. So instead of using the table, you can create a view of the table, which is maybe perhaps a subquery of the table. Select everybody from this table with the last name, Hecker, and then on those records, that's part of the view. That's going to be my records or something. So presents data from a different format than the underlying tables. Instead of getting everybody, you're just getting a subview. For security, simplicity's sakes, for complex queries. The query runs a little bit faster in a subview once the subview is created, and then you're taking the subview and you're running multiple queries on top of that because you have a smaller search space. So the queries actually run faster on views. But there's overhead in creating the view. Plus, if you create a view and you're going to update the view, then only one view from one table works. Multiple tables involved, you can't update the view. You can only update a view that's based on one table, one single table. So here's creating a view, and you have to create view with a view name as a select star from something. So here we go here. Select star from view name. So views can be queried just like tables can be queried. So simple view is based on SQL query, retrieves data from a single table, supports insert, update, and delete. So you can do a lot with a single view table, which means it's based on a single table as part of the single view. Complex views use more than one table. You can't update that or delete that. Yeah.
Updating a view will not change the table data.
It does. When you update a view or you delete a view, you delete something in the view. If you perform an insert, an update, or delete on a view that's associated with one single table, it works on the table. It goes straight through the table, and you can add a record to the table. So even though you're using the view, it's a straight pass-through, and it updates, inserts, or deletes the inside of the table. When you have multiple tables that are part of a single view, not possible. So they call that a complex view. Based on a query that retrieves data from multiple tables, you can only be used to support the select operation. You can only select, it's read-only. So you can select and read it, but no DML operations are supported. Because how are you going to do it? You're going to go back to 5 different tables and update every one of those tables? You can't do it. Plus, how do you know if an update's needed? It takes too much logic. It's too complicated. So single views working on single tables can be updated and modified, no problem, no restrictions. But multiple tables underneath that view, completely locked out of it. It's just read-only. So I know I'm going to have a multiple choice exam question on that, actually. I ask that every time because everyone misses it. They go, oh, you can't update a view. Like, certainly you can. If it's based on one table, sure, why not? You can update a view. So just think there's restrictions to updating views if they're on multiple tables. If it's on a single table, you can do whatever you want with it. And by the way, as I mentioned, the final exam is going to be in 2 weeks, and it's going to be multiple choice. So I ask you questions about, can you do a group by with an order by? Well, that's multiple. That's true, false, but there's some true, false in there too. Or if you do it, or which field do you use in the group by? And here's a sample query, and what field should you put in the group by? And you select A, B, C, D. So you don't have to write any SQL queries, but you have to look at queries and answer some questions about them. So. And then, obviously view, that question I told you about a few seconds ago. There's a question on updating a view, and it asks you, is it possible? And one of the questions says, no, under absolutely no circumstances is this possible. And then maybe one of the options will say, yes, if the view is based on a single table, which would be the correct answer. Or B, or C, whatever, no, entirely, not, well, if you drop the tables and recreate the tables, or, other options. So. Indexes. So an index is a separate table. So sequences keep ordered lists of numbers, and they're just a list concept. Well, it's an index. It's a numbered list. An index is made on a table. So sequences and indexes are 2 separate things. This is another question on the final that usually throws people off. I'll say, can you include an index value in this query? How are you going to put an index value in a query? Sequence value you could put in a query, but you can't put an index value in a query. Indexes you don't even see, you don't even use the indexes. You take the whole table, you create an index on it, you search the index. So the database does automatically, Oracle will put an index on every single table that has a primary key, and it's the primary key that's indexed. You can take off the index. If you can take off the index, it's going to make your updates work faster. However, your searching is going to work slower. So if you have a database table created and you're going to update the table, then if it's a lot of data, if you pulled the indexes off, it would actually update faster. You go to query the data, you're done populating the data in the table, you put the index back on, and then the table gets queried faster, but every one of the updates takes longer. You can update a table that has an index created on it, no problem, it just runs slower. So if you know you're going to use the table for searching and you're not going to use the primary key to search on that table, you're going to use another key, you can apply an index on the other key. So you can have more than one index per table. Automatically you get one with the primary key. But if you're using multiple keys to search, you might want to create your own index. The more indexes you create, first thing that happens when the query comes in is the query processor will go, do we have an index? Oh yeah, here we are. Here's one right here that matches that search. And I select, non-primary key, but I'm selecting it. If that one's indexed, if the select condition is indexed, there's an index table for it. It'll search the index table instead of the underlying table. Faster lookup, much faster lookup. The more indexes you put on it, though, for each new index you put on it, slower update. Just compounds the problem even worse. So you have a separate table that's maintained that shows the index keys and the physical locations, or it's a pointer table. So you have the primary key, and then you have the memory index. where it is in memory because it's not going to go off to memory. It's going to use the index for a faster look at. So the row ID is to translate it to a physical location of a row on a disk. Think of it like a pointer value. Improves response time, especially for joins. You index the two tables on the join condition and that runs much faster because it's going to join in the indexes and then use the index as the underlining query, the joined index. So you can't join an index, you can only join two tables, but you can create the indexes on join conditions. So indexes, you can create table index after the table is populated with the data because indexes make the insert, the update, and delete operations much slower. So indexing strategies. So a table might have multiple indexes on multiple fields. You create them on the search fields or the join operations. Whatever you're going to use for a join or for a search, if you index it, it will run faster. So typical indexes only speed retrievals when less than 15% of the table rows are involved. If you have a lot more table rows, then you're getting at about efficient speed. You're not getting that much higher. So it's when you're searching a smaller number does the index actually make sense. So each additional index adds processing overhead for the insert, update, and delete. So although you can do it, probably not such a good idea to have too many indexes. Or if you're going to plan things out correctly, search on your primary keys, and then you know your primary keys are always indexed. So you can actually do this. You can say create index, give it an index name on this table name, and give us on this field in this table. So here's a create index s_last index, and it's on student's last name. And so then we use the index. So actually, we don't have to. In Oracle, the indexes are used automatically. Those are user-created indexes. We already have one on the primary key, unless we turn the indexing fields off, which we can do if we want. So synonyms, alternative names for tables, allows you to not have to prefer the table with the owner name and the query information that belongs to another user. So you come up with a pseudo name. It's a synonym, pseudo name for the user's tables. So synonyms here can be created from the DBA account. So create public synonym name for owner name.table name. You're creating an alias. Instead of going this dot this dot this dot this, you're just going to call it something. You're going to call it HR. Easier to remember. It's kind of like a domain name for instead of an IP address. A little easier to remember. All users with privileges to use the tables can use the synonyms instead of owner.tablename. So it makes it easier to look at. This is the public synonyms. You can also have private synonyms within inside of your account that the admin is not going to create, but the user is going to create. Where you can create a private synonym for any table that you have privileges to. You can only use a synonym. Nobody else can use it because it belongs just inside your account. So whatever you guys create inside of your accounts belongs to you, unless you give ownership or you have admin privileges to grant rights and privileges to other users, which you don't have. Which means if you create your own synonyms, they'll be inside of your table. Probably no need to create one in a small database, but in a bigger one it might be hard to figure out what table name was that and what table name was that over there, and so you're creating an easier lookup system for the table names. Alright, so that actually was a little bit of a review of everything we covered. We covered a lot of stuff in the first weekend because I did a lot of lecturing. So what we're going to do now is break for lunch, and then after lunch we're going to do a database exercise. So when we come back from lunch, I'll start you all at the same time. And then for those people who are still having problems getting connected, I'll go around and help you individually after lunch, because it's a little bit easier that way. Not a bad idea to take a break. So let me stop this video, actually.